We would like to demonstrate using Apex to design a typical illumination system. As part of this process, we're going to show you the workflow for using Apex, which consists of defining the geometry, creating the sources, performing ray traces, and then doing analysis. Let's start by creating the geometry. We're going to do this by opening up a new part. So what I'm going to do is to create the shape of my reflector. I'm going to create a surface on my right plane. So I'll come in here and select normal 2. And then what I'm going to do is to create a nice simple spline surface to represent the shape of my reflector. So I'm going to assume I'm going to position my source somewhere near the origin. So I'm also going to start my spline curve near the origin. And I'm just going to create a couple of points to represent my reflector up here and then tail back in at the end. Okay. And now what we might want to do is set some dimensions and constraints upon this. So what I might do is use a smart dimension to make sure that the opening in the back of my reflector is large enough for my LED, but not overly large. So what I'm going to do is set a radial height of 4 millimeters. The other thing I'm going to do is constrain the total length of my reflector, and let's set that to 100. Nice even number. Next thing I'm going to need is this is the shape of my surface, and I'm going to create a revolved surface, so I'm also going to need a center line to act as an axis of revolution. So I'm just going to come in here and draw my line segment, a construction line, and possibly, since I said I want to put my LED near the focus, what I want to do is make sure that my reflector starts around the origin. And I'm going to zoom in a little bit to do this one. So what I want to do is put a constraint on these 2 points that they are aligned vertically. And then click on OK, and I can exit out of this sketch. And now what we're going to do is just simply create a revolved surface using this as my sketch, and here's my reflector. So I'm going to accept that. This is the end of my reflector design, and what I'm going to do is use this in my illumination system. I'm going to come over to my optics manager here, and I'm going to select this part, and I can apply the optical properties. In this particular case, what I'm going to do is simply make it a perfect reflector, so all of the light that reaches the surface gets reflected. I could also define coatings to have other properties as well, but again, for this example, let's take something simple. And now I'm going to save this file. And I'm just going to call it reflector. And then I will use this within my Apex assembly. So let's minimize this. And for Apex to create my entire system, which is my reflector as well as any sources that are necessary, I need to create an assembly. Now that I've opened a new assembly, the reflector is still open, so it's one of the open documents. I'm just going to click on that to select it, and click here to position it at the origin. If I go to my Optics Manager page, you'll notice that the optical properties previously assigned are still associated with that geometry. Next thing I need to do is insert my source. And in this particular case, what I want to do is use an LED from the light source library that's included with Apex. So I can come up here to my source menu item and select Manage Sources. You'll notice a wide range of sources, filament lamps, arc lamps, CCFLs, but for this design, I'm going to select an LED, and I'm just going to pick this particular LED. Any one of them could work, but this is a good size for the opening in our reflector. For now, I'm just going to create a simple ray set that's based on the properties of this particular LED. I'm just going to create one ray set from one wavelength. We could do others, multiple wavelength, but again, this is a simple example of how to use Apex and the Apex workflow. So now we've created the ray set. Apex has positioned the geometry representative of that LED in our system. And let's make our reflector a little bit transparent so we can see where the LED is positioned. And I could move this LED to an exact position. Let's zoom in. What I'd like to do is position it so that it's centered right here at the opening. And I can also check that position right there. And let's go to exactly 2.5 millimeters, but you'll notice it is centered in the X and the Y direction. And click on OK. So let's zoom out again. So now what we have is our reflector with reflecting optical properties. We have our LED with a radiometrically accurate ray set. And now we can do the third step in our process, which is to trace the rays. I can select the trace settings, and the trace settings allow me to make changes to some of the system parameters. My ambient medium is air, my wavelength units are nanometers, and my power is lumens. Typically, I don't need to change a lot of these items, but I do want to change this item under Ray Trace Display. Recall, our ray set has approximately 100,000 rays. I do want to see a visualization of the rays going through the system, but not 100,000 of them. Why don't we look at simply every 1,000th ray? So we'll see a total of about 100, a reasonable number. And also, I want to see the rays as they're exiting out of our reflector. So since our reflector has a length of about 100 millimeters, I'm going to set this to be 125. So I'm going to see the rays extend out after they reflect off of the surface, or simply the rays coming from the LED that don't interact with our geometry. Click on OK. And that's all of the housekeeping we need to do. And now we can simply choose to trace rays. In very short order, our ray trace is done, and we see initially this visualization. We see the rays that are leaving the LED, and if we follow these light paths, we can see that some of the rays just exit the LED and exit from the reflector without interacting with it. We see several rays that might reflect off the system once, and then we see other rays that reflect multiply off the surface. Now what we want to do is get information about what is the directionality of the light coming out. Would this be a good reflector if we needed to illuminate a table a few feet away or something very close to the output? So to analyze this, I want to look at the information in angle space. And I can choose my Analyze tab here, and this shows some, but nowhere near all of the analysis capabilities available in Apex. Some of the information is numerical data. Others will be more visual or graphical. I'm going to start by looking at an intensity plot in direction cosine space, so I'm going to click on this option. I can also at the same time convert this data to angle space, and I'm going to choose that option. We're going to look at all of the rays that are coming from the system, whether they hit the reflector or whether they came directly from the LED. So I will accept these defaults and then click on OK. And what we can see is some information about the output. This is the concentration of energy, again, in an angle space. And here is a false color plot of the same information. And in angle space, what we can clearly see, as most of the rays are coming out within small angles of the axis, but we do have some rays that are coming out at larger angles. Some of the rays that, as we can see back here in our model, hit at these severe angles and then headed off into space. Okay. It's hard to really get an angular picture from this or get sort of numbers from this. So what I can do is come to my analysis tree, and I can look at a distribution section of this data, a little bit clearer to see. I'm going to look at it in the XY plane through the maximum peak value. And just click on OK. And what we see here very clearly is that most of our energy is indeed within a range of plus or minus 10 degrees from the axis, although there is a little bit of energy in the tails, and most of this is due to multiple reflections off the reflector or some of the rays that came directly from the LED. You'll also notice information over here in the results tree. We see that we have performed this one ray trace, and we have looked at several pieces of analysis. Also have the ability to rename all of this data to something that might make sense later on when we come back to look at the data. So maybe I'm simply going to call this trial 1. Okay. So this is my first analysis. Now what I could do is make modifications to my system and then do further analysis. So what I'm going to do now is first off save my file, and we'll just save this as an assembly file. I can also call it reflector, but since this is an assembly, not a parts file, I'm not going to overwrite the original data. Let's just click on Save. And if you remember, we had left our reflector part open. Now what I'm going to do is go back into this parts file, and let's edit the sketch a little bit. So let's make a slight change in our design. So here's our original spline curve, and what we're going to do is change it a little bit and see how it affects the performance of the system. So the easiest thing might be to select one of the spline points and then just simply adjust the shape of it. And I want to make it not a significant change, but somewhat noticeable. So how about something like this? Probably not a good reflector, but again, it will show that we have made some changes. I'm going to exit the sketch and minimize this again. And you'll notice that the assembly realizes I've changed the drawing that makes up the assembly. So yes, I want the assembly to be updated to reflect those changes. And let's reopen it. And we can now see that our new reflector has been inserted. The old ray trace is still there, so you can see that the rays are no longer incident on the reflector, but that's all right. All we have to do is come up to Trace. Now we have a ray trace based upon our new reflector design, but you'll notice the information about the prior ray trace is still available. So I can go back and look at that ray trace. I can perform further analysis on that ray trace, or I can look at the information based upon our new design. So let's take a look at the similar type of analysis. So again, we're going up to the intensity and cosine space, and we're just going to select OK because it's the same settings as previously. And again, we'll do a distribution section through that data in the XY plane. So in this orientation, through the maximum peak value, we can now compare the outputs. And we actually, despite that significant change in shape, didn't really change the angular spread, although we do have much more energy coming out closer to the axis. You'll notice the peak value is much higher here. We can also look at the differences in the intensity plots as well. Okay. And of course, I can rename this to trial 2 or some other appropriate name. So this is a key capability of Apex, is that all of the information about all of our trials is available to us, and we can go back and reanalyze it at any point in time. We also have multiple configurations to store each of these various designs, and again, in real time, compare the results. So what we've looked at is designing a complete illumination system using Apex, following the 4-step process of defining the geometry, defining the sources, performing ray traces, and then doing any number of forms of analysis.